Hey friends, welcome to my video on sizing of neutral earthing resistor. Neutral earthing resistors, sometimes also called as neutral grounding resistors, are used in AC distribution networks to protect equipment from damage in the event of an earth fault. A NER is generally connected between the ground and the neutral of a transformer or a generator. NERs reduce the fault currents to a maximum predetermined value that avoids a network shutdown and damage to the equipment, but allows sufficient flow of current to activate protection devices to clear the fault. So why do we need a neutral earthing resistor? Well, an NER helps in reducing the fault current, thereby enabling many benefits to the electrical system, such as reduction of physical damage to the equipment, extended life of connected distribution equipment such as transformers, reduced operation and maintenance expenses as the electrical equipment do not experience a high fault current. NER provides a reliable, simple, and selective means of protection. It reduces risk of electrical shock or arc flashes that may pose a risk to personnel and equipment. If an NER is not there, then there is a possibility that high earth fault return current starts to interfere with your telecommunication equipment. Ground fault which flow through the soil can pose a danger if the step potential exceeds the safe limit. NER limits this fault current, thereby keeping the step voltage within safe limits. There are two broad categories of resistance grounding: low resistance grounding and high resistance grounding. In both the types, the NER is connected between the transformer neutral and the earth ground. Low resistance NERs are typically rated from 100 amps to 400 amps and are commonly found on medium and high voltage system. These NERs are used where there is a high investment in capital equipment to limit the damage to the equipment, as a limited fault current prevents overheating and mechanical stress on the conductors. The resistance must be low enough to let high current flow and allow detection by the protective devices, which in turn will trip the circuit. Whereas the high resistance grounding is mainly used in low voltage systems, most common in 480 volts and 600 volt systems, and they limit the ground fault current to a very low value, typically under 25 amps. The low ground fault current means that just like an ungrounded system, the system can continue to operate on a single line to ground fault. The low fault current will typically not trip the protective devices during a single line to ground fault. It is necessary to install a ground fault detection system since the ground fault current is not interrupted due to overcurrent. These are frequently used in applications that cannot afford a shutdown or that must control ground fault voltage on the driven equipment. Let us now try to understand how to size a NER. For medium voltage systems, typically for 3.3 kV, 6.6 kV and 11 kV systems, the earth fault current is generally limited to 400 amps. NERs are often defined by the system voltage of the supply. For example, 6.6 kV NER. However, the maximum voltage an NER will experience is the phase to neutral voltage. Hence, the rating plate of a 6.6 kV NER will bear the phase to neutral voltage. For example, the 6.6 kV NER is rated for 6.9 divided by root 3, which is equal to 3.98 kV. In case of an earth fault, The phase is disconnected from the load. That is why the no load voltage is to be considered while arriving at the rated voltage of the NER. For the time rating of an NER, IEEE 32 specifies standard time ratings with permissible temperature rise over 30 degrees C ambient. The 10-second rating is applied on NERs that are used with protective relay to prevent damage to the NER and the protected equipment. The relay must clear the fault within 10 seconds and ensure that the NER doesn't reach a temperature rise of 760 degrees C. The 10-second rating is used to allow for multiple operations, which could happen when auto reclosers are used. However, most modern protection systems will operate within this time. The temperature limit of 760 degrees C, selected as per IEEE 32/1972, is based on the performance limits for the resistor material, the insulators, and the mechanical construction of the NER that was prevalent in 1972. With the current technology, it is possible to operate at higher temperatures, enabling reduction of NER size. However, this will be outside the scope of the accepted standard IEEE 32. The 30-second time rating usually indicates an NER specification based on liquid resistors. The long duration reflects the cooling time associated with this old technology. A time rating of 60 seconds is used for NERs when we need to limit ground fault currents on multiple outgoing feeders. Since simultaneous ground faults could occur in rapid successions on different feeders, a 10-second NER may not be adequate. The 60-second rating is applied with the maximum operating temperature not exceeding 760 degrees C. A 10-minute rated NER is used infrequently. The 10-minute rating is sometimes used in unique process applications requiring extended fault times. The 10-minute rating is applied with the maximum operating temperature not exceeding 610 degrees C. There is, however, a corresponding increase in the cost of the NER. The steady state time rating of an NER is applied where the NER is expected to be operating under ground fault conditions for more than an average of 90 days per year, and it is desirable to keep the temperature rise below 385 degrees C. Let us now try to understand how to calculate the ohmic value of the NER. The ohmic value of the NER is given by the formula R is equal to V by IF, where V is the phase to ground voltage. In our example, this is equal to 3.98 kV. And IF is the earth fault current, which in our example is 400 amps. Therefore, ohmic value of the NER is equal to 9.95 ohms. This concludes my video on NER sizing. Thanks for watching. I hope you enjoyed this video. If you would like to see more such videos on electrical topics, please subscribe to my channel and share with your friends and colleagues. Also, don't forget to click on the bell icon so that you don't miss out on anything.